Another concept or thing that I should point out is the thing called the critical point. What the critical point is, well, I'll show it to you in terms of a TV diagram. But this is the point at which your saturated liquid and saturated vapor states are identical. So you're basically at the top of the two-phase region on your TV diagram. So it's where your saturated liquid and saturated vapor states come together. And if you look at this on a TV diagram, let me just sketch it out here. So on the vertical axis we have T, on the horizontal we have V, denoting your specific volume. We talked about the two-phase region, so your two-phase region might look something like that. You have constant pressure lines coming across, you go through a phase change, and then you move up into superheated vapor. And over here, you're in the compressed liquid region to the left of your two-phase region. So you can have multiple lines coming through, each of them at their own specific P equals constant value. Now, what happens, your critical point is up here. So this is your critical point. And when you go above it, if you have a fluid that is at a certain pressure and you're heating it, it can actually exceed the critical point, in which case we refer to that as being a supercritical fluid. However, at the critical point itself, we have a temperature and we denote that TCR. And the constant pressure line that would denote the critical point, that would be at pressure P equals P critical with subscript CR. So that is the critical point, and it is something that we'll be using for a number of different cases. On the left-hand side here, if you recall, this is our saturated liquid line. And on the right-hand side, this is the saturated vapor line. So critical point, it is a thing that you'll have to recall for certain problems. Now, another thing that I should say about the tables that we just presented, we talk about F and G. When using the tables, subscript F denotes liquid, and subscript G denotes saturated vapor. So, for example, for a specific volume, we had V subscript little f. That is the specific volume of saturated liquid. We had V little g. That's the specific volume of saturated vapor. we have VFG, and that is the difference between the two. So it is Vg minus Vf. And we'll use that in calculating the properties of mixtures that are in the middle of the two-phase region. So when you're performing calculations in the two-phase region where you have a mixture of vapor and liquid, we need a way to be able to determine the properties, because we're not at the saturated liquid point, nor are we at the saturated vapor. We're somewhere in between those two. So when we're in the two-phase region, we have partial liquid, but we also have partial vapor. And when we're there, we use a quantity called the quality. And so the quality is defined as being the mass of vapor in our system divided by the mass total. So when you're way over on the right hand side on the vapor, saturated vapor line, you'll have a quality of 1. And when you're way over on the left hand side with saturated liquid, you have a quality of 0. So quality has bounding values of x equals 0 for saturated liquid, and x equals 1 for saturated vapor. So if we're in the saturated liquid region, so we're in the two-phase region, what we do is we compute the average value of properties So we're calculating the average value of a property. It's going to be of the liquid property plus the quality times the difference between your saturated vapor and the saturated liquid region. And that's why we present the difference in the charts. And so with that, you can evaluate the properties at a point somewhere in the middle. So if this is our two-phase region, we have a constant pressure line. Let's say we're someplace in here, and we want to know internal energy. It equals what? Well, we need to know the quality, and then from that, we can then determine the specific property that we're looking at. And if you recall from our pictures of the boiling vessel, this would be a region where we have the water interface all over, and we have a lot of vapor bubbles in here. So we have a mixture of both liquid as well as vapor in our system.